So section 7.3b, let's start with the problem that says 0 to 3 square root of 3 over 2. The top is x to the third. The bottom is 4x squared plus 9 to the 3 halves. So this literally means 4x plus 9, 4x squared plus 9 square root to the third. That third could be inside or outside, but do you see the square root happening? Because that's important. Let's rewrite it to look like that. So we would say the integration from 0 to 3 square root of 3 over 2, x to the third. It's going to be easier to work with when it's in square root form. 4x squared plus 9 to the third dx. So let's draw our triangle. I'm going to draw a little one here. Now I know it's on the hypotenuse because it says squared plus. And one leg is going to be 2x and the other leg is going to be 3. So I like to put my constant on the bottom or on the hypotenuse. Those are my two standard practices. So I'm going to put theta here. Now if I read this triangle, the easy way to read this triangle is tangent of theta, because then I'm going to be looking at the 2x and the 3. Oh, I need the square root on here. Square root, otherwise it doesn't work. So 2x squared is 4x squared, and 3 squared is 9. And when I add those, I get 4x squared plus 9, which is what happens when you square the square root. So it's important you have the square root there. So let's let tangent of theta equal 2x over 3. So then 2x equals 3 tangent theta. So x equals 3 halves tangent theta. It's a good starting point. So dx is 3 halves secant squared x. I'm sorry, secant squared theta, d theta. So we're going to plug all that in, and we're going to say the integration from 0 to 3 square root of 3 over 2. That's not going to be fun to carry all the way through, but we're doing it. We have x to the third, so x is 3 halves tangent theta to the third. And on the bottom, we have the square root of 4 times 3 halves tangent theta quantity squared plus 9, and all of that's the third power. And then out here we have d theta, which is 3 halves secant squared theta d theta. My theta kind of fell off over there, but we know it's there, so don't lose it. Let's move over a little. So we have 0, 3 square root of 3 over 2. Now 3 halves to the third. 3 to the third is 27. 2 to the third is 8. Tangent to the third theta. And we can bring this 3 halves up here. We sometimes do it later, but we might as well bring it up now. 3 halves secant squared theta. And on the bottom, I have 4 times 3 squared is 9, 2 squared is 4, tangent squared theta plus 9 d theta. Now notice these 4's cancel pretty. So we again have a 9 that we can factor out. By the way, if you can't factor out that constant, you've messed up somewhere along the way. So be careful in your math and make sure that you can factor that out. So we have 0 to 3 square root of 3 over 2. And on the top, 27 times 3 is 81, and 8 times 2 is 16. And I have tangent to the third theta, secant squared theta, so it's just algebra. So here we have 9 parentheses tangent squared plus theta plus 1 d theta. Okay, so I'm going to move that to the top of the next screen. Before I move it to the top of the next screen, we lost our third power here, so let's go back and put it in. So here we have to the third power on the denominator of both of those. So we close the parentheses there. So now we have this problem. So let's continue. The square root of 9 is 3. So we have, I'm going to pull this 81 over 16 out front because it's just a mess. So we have tangent to the third theta, secant squared theta. And then the numerator, the square root of 9, and the denominator, the square root of 9 is 3. And we end up with the square root of tangent squared theta plus 1 is secant squared. and all of this is to the third power, d theta. So we have 81 over 16, 0 to 3 square root of 3 over 2. I'm going to keep my tangent to the third theta, secant squared theta. Now, 3 to the third is 27. And then the square root of secant squared is secant, and it's the third power. So this is secant to the third power theta, d theta. Now, these secant squareds cancel with all but one of those secants. And I'm going to pull the 27 out. Do you see that the 27 and the 81? 3 goes into 27 3 times, and 9 goes into 27 3 times. And it goes into 81 9 times, which means we can do this better. 3 goes into 3 1 time, it goes into 9 3 times. And 3 times 27 is 81, so that works out well. So we're going to say 3 over the square root of 3 over 16, 0, 3 square root of 3 over 2. And here I have tangent to the third over secant. Tangent to the third over secant. Now, if I let u be secant theta, because it's in the denominator, du is tangent secant. There's not another secant in that problem, so that's not helpful. Let's picture this as 3 over 16, this 0 to 3 square root of 3 over 2. And we're going to have tangent to the third theta times 1 over secant theta, d theta. All we did is change the way it looks, because that reciprocal function is going to help me. So we have 3 over 16, 0, 3 square root of 3 over 2. Now, secant theta, let's put them in terms of sine and cosine. So here, tangent third becomes sine to the third theta over cosine to the third theta. And then secant is the reciprocal of cosine. So here we're going to have a cosine theta, d theta. So 3 over 16, 3 square root of 3 over 2. Sorry, that's a 2, not a 3. So this cosine cancels with one of these, so we still have 2 of them. So we have sine to the third theta over cosine squared theta, d theta. Now again, we check u sub because it is our best tool. So if we let u be cosine theta, du is sine theta, that doesn't help me with the sine to the third. So we're going to use a different identity. Let's use the sine squared plus cosine squared theta is 1. So I need a sine squared here. If I don't, I'm liable to lose it. So let's say sine squared theta, sine theta over cosine squared theta, d theta. So now we're going to have 3 over 16, the integration from 0 to 3 squared root of 3 over 2. So sine squared is 1 minus cosine squared theta times sine theta over cosine squared theta, d theta. Now, if we let u be cosine theta, du is sine theta, oh, that works out very nicely here. So let's pick this up on the next screen. Let's let u equal cosine of theta. Then du is negative sine theta d theta. So d theta is negative 1 over sine theta du. So we have 3 over 16, the integration from 0 to 3 square root of 3 over 2. So our numerator is 1 minus u squared times sine theta, and the denominator is u squared. And then our d theta is negative 1 over sine theta du. So the sine thetas cancel. And let's take this negative 1 out to the front as a constant. So then we have negative 3 over 16, the integration from 0 to 3 square root of 3 over 2. We have 1 minus u squared over u squared du. Now remember, there is no product rule and there is no quotient rule. So let's split that fraction. We got negative 3 over 16, 0 to 3 squared of 3 over 2. And then we have 1 over u squared minus 1 du. Now most people don't integrate that well, so let's write another line. What's one more line than this problem, right? So we have u to the minus 2 minus 1 du. Now we can integrate. So we have negative u to the minus 1 minus u from 0 to 3 squared of 3 over 2. Now remember, since I'm working in trigonometric functions, before I go back to them, I need negative 1 over u minus u from 0 to 3 squared of 3 over 2. Now I like my 3 over 16 out front, but how about if we distribute that negative so that we have positive symbols everywhere before we go back into our thetas? So remember that u equals cosine theta. So we have 3 over 16, 1 over cosine theta, plus cosine theta from 0 to 3 squared of 3 over 2. So you could make that 1 over cosine theta a secant theta. We may have done that before, but I'm going to look at it a little differently this time. So let's continue from there. So remember, theta is not our original variable. So we need to bring our triangle back so we can figure out what's going on with that. So over here is where we started. Sometimes it'll actually ask us what tangent of theta is, and we can read that. But it asks about cosine of theta. So cosine is adjacent over hypotenuse. So it's 3 over the square root. And we have 3 over 16, and then we have 1 over that, which means we're looking at the reciprocal, which is normally cosine is 3 over the square root. So this is the square root of 4x squared plus 9 over 3 plus, and then cosine is 3 over the square root of 4x squared plus 9 from 0 to 3 squared of 3 over 2. So now we get to evaluate. We have 3 over 16, and here we have the square root of 4 times 3 squared of 3 over 2 plus squared plus 9. The symbols start to run together, so I don't know that squared can be any more clearly written. And then we have 3 over the square root of 4 times 3 square root of 3 over 2 quantity squared plus 9 minus 3 over 16. Now on the top we have 0 squared, which is 0, times 4 is 0, plus 9 is 3, so we have 3 over 3 here, plus 3 on the top, and 0 plus 9 is 3, and the square root of that is 3 here. So we have 3 over 16, and when you look at this, the square root of 3 squared, well, most of you are not going to do this in your head, but I'm going to do it. So we have the square root of 4, and this is 27 over 4, plus 9 over 3, plus 3, and here we have the square root of 4 times 27 over 4. 3 squared of 3 squared is 9 times 3, which is 27, just in case you're wondering where that came from. And here I have 1 plus 1 makes 2. Now let's go back to this. So if 3 over 16, 27 plus 9 is 36. The square root of that is 6 over 3 plus, same deal, 3 over 6 minus 3 over 16 times 2. Well, this is 2 and this is a half. So we have 3 over 16 and I have 2 plus 1 half minus 3 over 16 times 2. I would skip some steps here if this were up to me. So I end up, when I distribute, we have the 2's are over 1. So we have 6 over 16 plus 3 over 32 minus 6 over 16 equals 3 over 32. What a sense of accomplishment. This last example is probably not going to be your favorite. Depends on how good your pre-calc skills are. So I have the integral, the numerator is x, and the denominator is 3 minus 2x minus x squared with respect to x. Now the problem is it's not that cut and dried, like we've looked at the square root of something like 9 minus x squared, where the square root of that is 3, and the square root of this is x. So we need to get it into that form, and in order to get it into that form, we have to use completing the square. So let's go back to your algebra for a minute, and let's make a note here. So let's do 3 minus 2x minus x squared. It's an expression, so let's factor out a negative, and let's say 3 minus 2x plus x squared. So we factored a negative out of those. Rearrange it. 3 minus x squared plus 2x. Now to complete the square, you have to have a leading coefficient of 1, so x squared can't have a number in front of it. We're good here. Plus 2x plus something, and whatever we add here, we want to do the opposite out to the side. Now we take, to complete the square, we take half of 2 to be 1. Squared is 1. And it's technically a negative 1, so it's a plus 1. There's maybe a better way to explain that to you, but we're going to add the 3 and the 1 to be 4. Minus, and this factors into x plus 1 times x plus 1. So we have 4 minus x plus 1 quantity squared. This is probably the tricky part because there's a minus out here. So this minus right here says that technically I'm adding a negative 1. When I distribute, that's a negative 1, so I need a positive 1 to balance it. So we can rewrite this problem. Let's stick back in this color. We can rewrite this problem to say the integration of x, and in the bottom now I have 4 minus x plus 1 quantity squared dx. So you can see that the square root of this is 2 and the square root of this is x plus 1, right? But we don't really want to carry around x plus 1, so let's go ahead and use u sub and get that out of the way. So let's let u equal x plus 1. So then we'll end up with 4 minus u squared. Then du is dx, so that's all good. But we have to take this, and we need to solve for x. So x equals u minus 1, because we have to substitute it on the top as well. So we rewrite this problem to be u minus 1, and in the denominator, we have 4 minus u squared du. So now we can start the trigonometric part of it. So let's build our triangle. I know this is a leg because it has a minus. Let's put it over here this time. The square root of 4 minus u squared. This is 2, and this is u. So if I do Pythagorean theorem, 2 squared plus u squared equals the square root squared, so we're good. And then theta. So let's let sine of theta, because I want to use the 2 and the u, equals u over 2. So u equals 2 sine theta. So du equals 2 cosine theta d theta. So now we have the integration of u, which is 2 sine theta minus 1. And in the denominator, we have 4 minus 2 sine theta quantity squared. And in place of du, we have 2 cosine theta d theta. So we have 2 sine theta minus 1. And here I have the square root of 4 minus 4 sine squared theta times 2 cosine theta d theta. So let's keep going. Let's factor out that 4, and the square root of that would be 2. And we have the square root of 1 minus sine squared theta. Here we have 2 cosine theta d theta. We keep carrying that through. 2 sine theta minus 1. You can't cancel the 2 on the top with the 2 on the bottom because there are 2 terms in the numerator. But you can cancel the 2 out there with this 2. You can cancel the 2 in the parentheses because it's a monomial. So we have the integration of 2 sine theta minus 1. And 1 minus sine squared is cosine squared theta. And here we have cosine theta d theta. So we have 2 sine theta minus 1, and the square root of cosine squared is just cosine, and out here we have a cosine, so life is looking pretty nice. We can cancel these. So we have the integration of 2 sine theta minus 1 d theta. So we have the integration of 2 sine theta minus 1. The integration of sine is negative cosine, so this becomes negative 2 cosine theta, minus the integration of 1 is theta with respect to theta, plus c. Okay, so off to the side are all of our notes over here. So let's go over there. We have negative 2, and then cosine of theta is adjacent over hypotenuse, so it's the square root of 4 minus u squared all over 2. Minus and theta, if we go back over here, u equals 2 sine theta. So if we solve that for theta, we can say that, let's see, u equals 2 sine theta. So sine theta equals u over 2. So theta equals inverse sine of u over 2. That's the angle. It's asking for the angle, not 1 over. So we have inverse sine of u over 2 plus c. Now u is not the variable we started with. U equals x plus 1. So we're going to say negative 2. Oh, those 2's can cancel. So we just have the negative in front of the parentheses. So we have negative, in front of the square root, 4 minus x plus 1 squared minus inverse sine of x plus 1 over 2 plus c. Now, I'm perfectly happy with this answer, but you can always expand it back out. That's probably what WebAssign wants because that's what's in the textbook. So we have x squared plus 2x plus 1. They put it back. What I mean by that is they put it back into the form it came from. Minus inverse sine of x plus 1 over 2 plus c. So we have negative square root of 4 minus x squared plus 2x plus 1. Oh, let's distribute that. That's what's supposed to be happening here. X squared minus 2x minus 1 minus inverse sine of x plus 1 over 2 plus c. And then we have negative 4 minus 2x. Oh, 4 minus 1 combine like terms. 4 minus 1 is 3. So we have 3 minus 2x minus x squared minus inverse sine of x plus 1 over 2 plus c. So that's the other form of the answer. And if you look back at the original problem, that was the square root we had in the denominator. So that gives us the answer. Not the favorite method, but it's a method you need to be able to use and understand. So as you work through this section, be careful with that, with those concepts. Thank you.